Yeah, in overview, yeah, we learn about the neural network, and we know that the neural network is a set of connected neurons. And in the neural networks, we have input layers, hidden layers, and output layer. And in this section, we also learn the forward and backward propagation. Whenever we use the neural network during the learning phase, the network learns by adjusting the weights. So we know weights from the previous section. Yeah, the weights. Here are the weights. It will always be adjusted to find what is the best weight in order to give the prediction. And we need to have a loss function. So this function will tell us how good our neural network for a certain test. So we have the loss function for binary classification. We have the loss function for multi-class classification. We have the loss function for regression. And the backpropagation algorithm is the most common learning method, and it has been successfully applied to a variety of learning tests. Okay, the remaining are the reference. So if you want to check the reference, yeah, you can have the reference. And in orange, they also have the neural network. So if you want to apply the neural network, the simple neural network, you can just use orange. For example, I want to apply to this data set, which is iris. You know, iris data set, we have 3 flowers, the iris setosa, iris virginica, iris versicolor. And you can directly apply to the neural network. You can go to the neural network here. And then they have the basic parameters. So the neural network will give you this neural network widget. They have the default parameter for the number of neurons in hidden layer. What is neurons? It is the number of units. So if you still remember when we do with this neural network, we have 2 units in the hidden layer. So if we have 100 neurons, it means we have 100 units. So how can we determine that unit? Yeah, it depends on the data, it depends on your definition. But based on these default numbers, it's the best numbers. And we have many activation functions. We can use the identity, we can use logistics, we can use Penguin, we can use ReLU, okay? So the logistic, what is logistic? Logistics is the function that we learn. This one, okay? So the sigmoid, we can also mention it as logistic. This is the activation function. Okay. So the name is sigmoid activation function or logistic activation function. And if you look at the solver, okay, I didn't explain this one, but they have some algorithms to solve the problems in optimized way. The regularization means the learning rate. So we can have this alpha as the learning rate. If you can see, this number is very small, 0.0001. You can increase this one, or if you want to use the very small number, yeah, that is the recommendation. It is better to have the low learning rate. I guess we already learned from the basic concept. So if the learning rate, yeah, if it is too large, then it will take more time. And also we have the maximum number of iterations. This is the max iteration. And if you want to check the result, same with the other algorithm, you can go to the test score and then you can look at the data. In this case, I'm using the cross validation, and the classification accuracy is 0.947. Then you can compare with other approach. Let's say I have the decision tree, okay, and then I have another, let's say the KNN, and let's say I have the naive bias. Then if you put all of them in the test and score, you can do the comparison. If using the KNN, then you will see 0.96. If you use the tree, you can see 0.96. Okay, the neural network shows 0.94, and the naive bias shows the 0.87. Then from these algorithms, yeah, we can choose the best one. In this case, the best one is the KNN. Okay, and that's all about the neural network. Now let's move on to the new section, which is the alternative of clustering. We already learned the basic clusterings, the basic concept of clustering, and we learned about the partitioning methods, and we also learned the hierarchical methods. So in this section, we will learn the remaining three. We will learn about the density-based methods. We will learn about grid-based methods and some evaluation of clustering. Density-based clustering methods. What is density? Clustering based on the density or local cluster criterion. Okay, the local clusters. This is the main point. So the local cluster criterion, it means the density connected point. The major features, we can discover clusters of arbitrary shape. What does it mean by this one? Arbitrary. Arbitrary means any shape, every shape. Okay? So if you use k-means, maybe the shape is like circle, like this one. But sometimes your data might be in the like L shape, or the data might be in the triangle shape. Okay. And the other major features, it can handle noise. It is one scan. It means we can just have only one time processing, and it requires density parameters as the termination condition. So we need to have one condition to stop the iteration. There are some interesting studies. We can use DBScan. It was developed in 1996. Optics, then Clue, and Click. So our part in this density-based clustering, we will learn about DBScan. And we will learn Click later, but it is not in the density-based, it is in the grid-based later. density-based clustering. So we can have two parameters. The two parameters, first is the EPS. EPS means the maximum radius of the neighborhood. For example, I have the P. Okay. This is the data P. So I can have the radius. It means if the radius is 1 centimeter, so it is the 1 centimeter from this data, and then we can make the surrounding area of this particular data. Okay. So we determine that every data in the radius of 1 centimeter. And then we have another parameter which is minimum PTS. So the minimum PTS means the minimum number of points. The minimum number of points, if we set it is 1 centimeter, and then let's say I have the minimum PTS is 5, then at least in this data or in this area, there should be 5 points. So for example, in this example, I have this circle. So we have 1, 2, 3, 4, 5. Okay. So if it is 5, then we can make one cluster. And then we can see what are the elements of that particular clusters. We want to check if we want to start with the point P. Okay, if we want to start with the point P, then what are the nearest neighbor? N means the neighbor. Okay. We want to check the neighborhood. The neighborhood means if the Q, okay, Q means every other point. So we want to check what are the points where the distance between P, between one particular point to another point, and the distance is less than or equal to EPS. So if the distance is less than 1 centimeter, then it will be included in this N or in this neighborhood. We have the word directly density reachable. It means a point P is directly density reachable from a point Q with regard to. So WRT means the with regard to. We have two parameters, which is EPS and mean points. If P belongs to the NEPS. What is NPS? NEPS is the neighborhood. So this is the neighborhood. And then the core point condition. Core point means if every of the point is in the neighborhood, or this is higher than or equal to the minimum PTS. Minimum PTS is 5. Then if we have 5 points, we can say that it is directly density reachable. There are two different concepts, okay, about the density base. The first is density reachable. The density reachable means if we have a point P, it is density reachable from a point Q. Okay, we have P. It is reachable from Q with the particular EPS with a particular minimum points if there is a chain. You know chain? If there is a chain, it means I can go from Q, okay, In this case, I have P1, P2, P3, P and so on until Pn, such that the P I can reach it from Q through different point. So the Q1 can reach P1. But as you know, Q is very far from P. However, the Q reaches P1 and the P1 can reach P. So we call this is density reachable. This is not directly density reachable, but this is density reachable because there is a chain of point. We have Q and then we go to P1. P1 is directly reachable and then we have P. Okay. Density connected. In the density connected, a point P is density connected to a point Q. A point P is density connected to point Q. With regard to the EPS and the minimum points, if there is a point O, where is the O? This is the O. There is a point O such that both P and Q are density reachable from O with regard to EPS and minimum points. It means I know that O, it is reachable to P, and then O, it can reach Q. Then, in this case, P and Q is density connected. So we can check with the algorithm. There is one algorithm, the name is DB scan. DB means density base. D is density, B is base, S it is the spatial. Spatial means like space. C is clustering of application with noise. So it relies on a density-based notion of clusters. Okay, the basic idea is the density base. And a cluster is defined as a maximal set of density connected points. What is density connected points? This one, density connected points. So if it is maximum, then we can create a cluster. And we can discover clusters of arbitrary shape in the spatial database with noise. So in this concept, we have three kinds of points. The first is the core point. What is core point? The core point, if it is in the EPS and there are let's say the minimum BTS is 5, so I can say 5. There are 5 points in the radius of the EPS. So the core point, let's say this one, this is the point, and this is the EPS, is 1 centimeter, and I have the 5 as the minimum point. So I can check. We have 1, 2, 3, 4, 5. Okay, we have 5. Then this point, we call it core point. Because in this point, the surrounding area of that point, we can create a cluster. There is another point, we call it border point. The border point, it is a point, and in the surrounding area, we have only one. Meanwhile, we need 5. Okay, so in the surrounding area, we have only 2 points. Each point itself and then another point. So we have only 2 points. Is it okay? Not okay. But at least not the only point. So we have still another point. That's what we call as the border point. We have another point, we call it outlier point. The outlier point is the individual point, like this. So there is no other point in the surrounding. So the algorithm works like this one. First, we select the point, and then we will retrieve all points. How we can check the density reachable? And we need to check based on the EPS and based on the minimum VTS. If it is a core point, what is core point? What is core point? The core point is the point that fit with the minimum points. So if it is core point, then let's make the cluster. If it is a border point, then no points are density reachable from P, and the vscan visits the next point of the database. So we can select another point. Continue the process until all the points have been processed. Let's see with example. Okay? It will be easier with example. Suppose we have 13 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. Okay. So if you plot, maybe the plot will be something like this one. So if you look at this data, maybe the cluster would be something like this one, and the cluster would be like this. But when you calculate it, you need to set the parameters. What is the parameters? Now let's assume that I have this one, EPS 0.6, and the minimum points is 4. What we need to do is to determine the cluster results and the outlier. So how can we deal with this one? Maybe, yeah, you can check this one. This is the core point. This is the border point. This is the outliers. Okay. But how we can determine this one? So let's do the calculation. The data number 1, data number 2, data number 3, data number 4, and so on, until we have the data number 13. The first is we need to calculate the distance between the data point number 1 and the data point number 2. What is the distance between the data point number 1 and data point number 2? If we use the Euclidean distance, then we have 1 minus 3 and then power of 2, 2 minus 4 plus 2 minus 4, power of 2, and then we know that it is the square root. So the square root of 2 power of 2 plus 2 power of 2. Okay, maybe this one is minus, but minus 2 power of 2 is will be positive. So at the end, we have the square root of 8. What is the square root of 8? Yeah, the distance is maybe like this one, 2.8 something. 2.8 something. Then this is the distance from 1.2 to 3.4. What about the distance from 1.2 to 2,5.4? Again, we can calculate. 1 minus 2.5 power of 2 plus 2 minus 4 power of 2. And then we do the square root. So we get the distance 2.5. Okay, and so on. So this is the distance from 1.2. Now we will check. Based on this one, we will do only the first part. Okay. Now we will do the neighborhood points. What is neighborhood points? We will check based on the EPS and based on the minimum points. The EPS is 0.6. Then we need to select every point which is lower than or equal to 0.6. This is 2.8. No. This is 2.5. No. This is 0.7. No. 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 Okay. This is less than 0.6. Next. This is no. No. Okay. This is less than 0.6. This is no and no. Then we have 2 points. We have 2 neighborhood points. So in the point 1.2, we have the first point, this one, which is 1.2, 2.5, and the other is 1, 2.5. Okay. So we have 2 neighborhood points. After we have this one, we select the next, which is from 3, 4. What is 3, 4? This one. So we need to make a new distance measurement. So we need to make a new column here. Distance from 3, 4. So the distance from 3, 4 to 1, 2. You need to give the distance measure. The distance from 3, 4 to 2.5, 4. Yeah, there will be another measures, another numbers. There will be another number, and so on. After you have those numbers, what will you do next is to check with the EPS. The EPS is 0.6. So you need to check which one the distance which is lower or equal to 0.6. So we get these 2 points, 2.5, 2.5, 4, 2.8, 4.5. And we need to select the next point, which is 2.5.4. And again, we need to make another column for the distance from the 2.5.4. So the calculation will be for every point. So we get like this one. So the 2.5.4, we have 1, 2, 3. We have 3 points. We have 2 points. We have 1 point. So this one we have 4 points. Okay. The minimum point is 4. So we have 4. We have 2 points. We have 4 points. We have 2 points. Okay, no point at all. We have 4 points. No point. No point. Okay, after this, we can determine where is the border point. What is border point? What is the border point? The border point is when the point have neighborhood points, but it does not satisfy the minimum points. The minimum points we have equals to 4, but we have only 2. This is also border point. The minimum point requires 4, but we have only 2. This is also border point, border point, border point. This is core point. Why it is core point? Because it's satisfied with the number of minimum points. We have 1, 2, 3, 4. So for every core point, we can generate the cluster. So this is one cluster. We have 4 points, 1, 2, 3, 4. This is another cluster. And this is also another cluster, 1, 2, 3, 4. But we can see that this cluster and this cluster basically they are the same. Why? This point 1.2, 2.5, it is here. And 1, 2.5, it is here. Then basically they are in the same clusters. If you look at those elements, so those are in the same cluster. So both point, we have this core point and we have also this core point, they are in the same clusters. What about the others? If there is no neighborhood point, then we call it this is outlier. No neighborhood point, we call this is outlier and outlier. So at the result, we have cluster 1. The cluster 1 we have with the following point 1, 2, 3, 4, 5. And the cluster 2 we have the following point 1, 2, 3, 4, 5. And the outliers we have 3 points. Okay. So this is the density based clustering. The DB scan is very sensitive to the parameters. When we have the data like this one, we call this is the data set 1. Let's say we want to set the minimum points at 4. So I want to have at least 4 in the surrounding area. But I want to check if the EPS equals to 0.5. But this one is 0.1. Then the result is different. You can see that this result is more, maybe you can see the shape. Okay, yeah, this is in the circle shape. But when you change to 0.4, now the shape is totally different. In the data set 2, this is the data set 2. If we set the minimum points equals to 4 and the EPS is 5, 3.5, and 3, then the EPS 5 is is better. You can see the shape in this polygon shape, and then we have this is you cannot see the shape. This also you cannot see the shape because we have the EPS which is less than the requirement. Then we can say that okay, let's use this one because it is more obvious. If we compare with the other kind of algorithms, the DB scan can show in the better point of view. So you can see in the better shape, like this one. Yeah, we can see the better shape. Okay. This kind of thing, yeah, it can be seen in the DB scan. But if you use another algorithm, mostly they will check maybe related to the similarity or the distance, and maybe this can be separated into two. Or if it is using the currents, you can see something like this one. Some data are mixed. So the benefit of the DB scan, yeah, you can select the data and you can find the proper result as the visualization. Okay, so that's the density-based method. Now let's move on to the next method, which is the grid-based method. The grid-based clustering method, it uses multi-resolution grid data structure. So some interesting methods, we can use STING. STING is a statistical information grid approach. It has been proposed in 1997. Then we have wave cluster, click. So you can use this as the grid based or the subspace clustering. What is STING? STING is a statistical information grid approach. STING, statistical information grid. Do you know grid? Grid is like the rectangular. Okay, we can make grid, so we can make a rectangular shape for every of the area. We can make several levels. Oh, sorry, this one. The spatial area is divided into the rectangular cells. So we can make this rectangular, okay, this rectangular, this rectangular, and so on. So there are several levels of cells corresponding to different levels of the resolution. So let's say this is the first layer or the top layer. You can go down. This is the I-1 layer. And you can go down again. You can have this is the I layer. The STING clustering method, we want to see from every of the cell. So if we have one cell at the top, we can see the lower cell with the grid. The high level is partitioned into a number of smaller cells in the next lower level. So the first we have only one cell, so we can see more cells in the lower level. And we can check the statistical info on its cells. And we will store it beforehand, and it is used to answer to queries. Parameters of the higher level cells can be easily calculated from the parameters of the lower cells. If we have the information from the lower cells, we can extract the parameters in the higher cell. At the same time, if we know the parameter in the higher cell, we can try to figure out the parameter in the lower cell. So most of the time, yeah, we can have like count how many data do we have. Mean, the average. S is the standard deviation. Minimum, this is the minimum of the values, and the maximum is the maximum of the values. And we have the type of distribution. You can define like normal distribution, or you can have the uniform distribution, etc. Most of the approach, they use the top-down approach to answer the spatial data queries. And it starts from a pre-selected layer, typically with a small number of cells. So if you have a very huge If you have a very huge cell like this one, you can select, maybe I want to focus on this cell. Then you can start to analyze using this cell. For each cell, in the current level, compute the confidence interval. So we can select the confidence interval and check whether it is statistically significant or not. So let me just use one example, but this example without the confidence interval. I have the n. What is n? N is the number of objects or the number of points. So in n, so we have, this is the cell number 1, cell number 2, cell number 3, cell number 4. Let's say then I have like this. Cell number 1, cell number 2, cell number 3, and cell number 4. Okay. Cell number 1, we have 100 data. And M, what is M? M is the mean of the values. So among 100 data, the average is 20. And then we have S is the standard deviation. And then we have minimum, which is the minimum value of this attribute cell. So among 100 data, the minimum is 4.5. And the maximum is 36. And we can see the distribution, which is normal distribution. This is the data in the cell number 1. What is cell number 2? Okay, this is the data. What is cell number 3? So this is the data. What is cell number 4? This is the data. Okay. Now, if I want to look at the higher level, so I want to make the higher level from this cell, it means I need to aggregate all the data. So now the data becomes 220. Why 220? 100 plus 50 plus 60 plus 10. Okay. We have 220 data. What is the average? We have 20.27. So we just do the calculation from this average. And then we have the standard deviation 2.37. Okay. We have the standard deviation for every cell. And we have the minimum is 3.8. How we can get this minimum? Here we can select from the minimum from every cell. And we have the maximum 40. Okay, from every cell, the maximum is 40. And the distribution is normal because every cell, 3 among 4, they are normal, but only 1 is null. Or we can just give notation that 210 points whose distribution type is normal. 10 data, we do not know the distribution. When we do the testing algorithm, we need to remove the irrelevant cells from further consideration. So for example, if we have like this cell, if you think that this cell is not that relevant, it is not relevant, then you can move or you can remove it. When finished examining the current layer, you can proceed to the next lower level. So this assumption is if we have the higher level, so we can go to the lower level. Repeat this process until the bottom layer is switched. So you can again check the bottom layer. And usually you cannot focus on every cell. You can just select on some cell like this one, and then you can make the lower layer. The advantages, it is query independent. So you don't need to do the query. Like in the SQL, you need to make query, but here you just make the top to bottom. Easy to parallelize, and it is incremental update. The efficiency is OK. OK is the number of grids at the lowest level. So we just do one time from the top to bottom or from the bottom to top. Disadvantages, all the cluster boundaries are either horizontal or vertical. So if vertical, it means we have from the top to bottom or bottom to top. Sometimes we can do with the horizontal. Horizontal means from the left to right or from the right to left. But no diagonal boundary. So we cannot like check from this cell and then we want to diagonal to this upper cell. So it is not possible. Okay, let me stop here. Let's have a break. I'll continue after the break.